Hello, alright, so this is my first video in a while, and I wanted to make this video because I wanted to create a series of really freaking fast LeetCode solutions that I did not make and explain it, and, I just wanted to make it because, why not show how cool unreadable code is, um, and how it works, and maybe you can implement it yourself in future stuff, which you probably shouldn't write it like how people write it, like in general, like this, but I still think it's really cool. Okay, so how I'm gonna order this series is I'm gonna do, I don't know, as much leak code as I could, but I'm starting in neat codes, first thing in his roadmap, and I'm gonna start from there, and it's gonna be C++ only. All right, I'm sorry, C++ only, and we're gonna go up from there. And this is what we're gonna start with. Okay, obviously you probably know this. Contains duplicate. This is a really common coding interview problem, and people most of the time they either sort it first, and then they iterate through, and they have indices, and they have one pointing at the first value of the array and one pointing at the second value, so index 0, index 1, and then it's almost like a sliding window. Or they have, if there's they have a hash map, and they're counting values, and if one is over 1, which means it appears more than once, then obviously there's more occurrences than one of that value, of that literal. Okay, so sorry if I really butchered the explanation, but that's how most people do it. Now this guy, does the first approach that I said, which is just sort it and then iterate it and compare the values. But instead of sorting first and then compare it, he does it at the same time. So let me show you this. Okay, first of all, I'm gonna explain this a little bit. Okay, over here. Okay, so first he uses a lambda function with an anonymous name, and the value of that the value that would be appended to it is called init or whatever. I don't know, I'm not British, so. And then that's obviously automatic, which is, you can't use this if it's C++ 20 or more. I mean the other way around, my bad. If it's C++ or 20 or more, you can use this. Otherwise you can't use that. So careful with auto. And this intakes some parameters. Okay. Now let's get to the juicy stuff. Okay, let's explain. All right, what's sync with Studio? False. What the hell is this? I saw this for the first time. I'm like, what am I looking at? Okay, I'm used to just solving LeetCode problems in Python, and I see this and I'm like, what the hell is this? And I took literally a day to understand just these 6 lines. Okay, the output buffer, writing to the compiler, C streams, C++ streams. Okay, all that freaking BS. So let's explain it as fast as I can and concise, so you know. So what does this do? So C++ used to be is almost an attachment of C, and C was before C++, and C++ was built on from C. Okay, so that's what stdio really is it's syncing with the old C streams. What does that mean? Okay, so what that means is, first we're gonna give you a little bit of history. So the C++ we all love and know was not always C++. It was actually stripped away from its 2 plus signs and used to be C. So there was C before, and then now there's C++. What happened? Some guy came in and was like, oh, okay, let's make cool stuff from C and add stuff to it. That's what C++ is now. Okay? Guy plus C makes baby called C++. Perfect. And now we have methods that have to do with compilers. Okay, that have to do with the compiler from C, and methods that do very similar things, but now they're renamed and they are slightly more specific, and now they're in C++, under C++. Okay, Now in C++, we still have both of those from C and C++. Imagine in Python, someone made a Python baby called Python++, and instead of saying print, it does write, but it does the exact same thing. That's kind of the same thing. Instead of stdcn, I mean, exactly stdcn, but in C++. stdcn, but in C, now in C, there's this thing called printf, okay? And they do very similar things. So, why do we want to unsync that? Well, that's because of the way they're interacting with the compiler and how they're doing stuff. So let's be more specific about this. What's really happening here? Sorry if you hear my keyboard. Very, very sorry. Okay, so let's say, how do things even show up in your compiler in the first place, you know? How does it even show up? Well, what it does is, I'm gonna give you a little bit, I'll give you an analogy first, and then I'll explain how it correlates to the code. So I'm just gonna do okay, so we have that, right? And then this is what we're gonna do. Okay, and I'm gonna do one last thing. Okay, we're gonna pretend my variable exists somewhere here, and it's the person's input is being put into my variable. So, why am I doing this? Why am I showing you this? Let me explain. Okay, let's say you have a duty in your day, and your duty is to keep your bucket empty, and your bucket is constantly filling. What do you think is more efficient? Do you think it's more efficient to dump out your bucket every like 10 seconds? Or do you think it's more efficient to wait till 10 seconds before the end of the day, dump it all out, and then you're good? Well, this is the exact same thing here. Do you think it'd be efficient for the code, for the runtime's cursor, to immediately flush, or let me explain what flush. Flush means to show it on the compiler. Do you think it'd be efficient to show it on the compiler, this, and then this, and then this, and then this, like one at a time when they're only a few milliseconds apart? Okay, no one's gonna notice that difference, all right, unless you're insane. Okay, no one's gonna notice the difference. So what's better is to wait till there's no more coutts, wait till there's some sort of correlation to know that all the coutts have been that you know to put it all out. So you know how the analogy I gave you is we know to put all the water out because it's 10 seconds before we have to have a bucket with no water in it. Well, instead of a bucket, we have this called cin. When cin happens, everything before it, all the coutts get flushed to the compiler instead of one by one, instead of this and this and this. You get what I mean? Okay, that's one way it does it. Another way it does it is if it sees this, then it flushes it out, right? Because it can't indent to the new line. Not indent. It can't go to the new line without saying what is before it first, right? And then the other way was if the program finishes and terminates. So there's 3 ways. There's a lot more other ways, but those are the 3 ways I noticed. Okay, the cin, which puts all of the cout, then program finishes terminating, and then new line. So how does Python save this and output it all at once? Well, there's this thing called the output buffer. Just think of it as a RAM for the coutts, but for the compiler. And it saves all of this, and then once the end or any of those 3 other conditions happen, then obviously it's going to get all flushed to the compiler, or it all shows at once. And that first method, the cin, which makes it all do that, it also happens for printf, which is an old thing from C. Now, if we're not ever going to use printf or scanf, and please correct me if I'm wrong, then obviously you can unsync it. That means, what that means is this won't make it flush out anymore. So that's what that does. And that under the hood stuff that makes it check the output buffer and all that, it won't happen anymore for printf. And now we got cin and cout, okay, and they're tied together. And what that means is, like I told you earlier, but instead of printf doing it, now it's just the normal C++ stuff that does it. And okay, so the cin does flushes all this stuff from the cout. Now disconnecting cin and cout from each other, okay, which is what 0 is. It's false or 0 is the same. Like this can be 1 or true. Those are the same too. 1 and true. Oops. 1 is true. 0 is false. So by making it disconnecting each other, that means we're making it so if we do cin, it's not going to flush it all out. It's going to have to be the 2 or other factors which causes it to flush out. So that eliminates a lot of under the hood code that C++ does and improves optimization and performance of your whatever you're doing. Okay, by like 1 millisecond. Yay, 1 millisecond improvement, guys. That's so much. Okay, now let's move on to this horrible, horrible, horrible thing. Okay, so first we make a class called solution, and we have a public method over here, which is a bool, and then we have a private, which is a bool. Then we're going to explain what this does first. First, it takes in the nums, which is a vector containing ints. And then we're going to do our switch, which is imagine an if statement. If nums.size equals 0, then return false. If num.size equals 1, return false. If nums.size equals 2, then compare nums.front and nums.back. If they're equal, obviously that means they're a duplicate. So this is like, oh, let's say we only have 2, okay, because nums.size tells you the size gives you how the number of values in that nums, okay. So let's say we have 2, right? So let's say we have 2 and 2, okay. Then compares the front, which is here, compares the back, which is there. If they're the same, they're a duplicate, obviously. If they're different, then continue on. Okay, so we have an auto constant begin equals nums.begin. So this creates a pointer iterator almost. This also does the same thing, but this points at the beginning, that points at the end. And the point of this pointing at the end is so we can compare it to this cursor for this for loop, which will act as our guiding man that will bounce around the array, okay, or the vector. So we have auto cursor, which is the man doing the job, equals begin plus 1. Then we have cursor, which does not, as long as this doesn't equal to end, then we can keep going. And we have cursor plus equals 1, which happens before each iteration. And then we have if sort cursor, then return true. Now what this does is the magic. This is the insertion algorithm and comparing in the same algorithm, which is insane. I don't even know how to like, I thought of that, but I didn't know how to implement it. But this guy did just implement it like absolute Chad. So then we're gonna do. Also, sorry for my lingo. I'm only 16 years old, and that's why I'm probably a bit uneducated. So that's why I'm saying, correct me if I'm wrong. Then we have the private here. Okay. So then we have a bool sort cursor, and also this is also kind of optimizing, because that kind of removes it from the list of methods it can call from outside of this public class. Only things can access contains duplicate. Things called contains duplicate it can access in the class solution. It's not going to be stored as a viable option to use outside of the class itself, if that makes sense. Sorry about that if I butchered that, but that's what private is cool. That's why it's cool. Save some memory, I guess. Then we have sort cursor, auto begin, auto cursor, which comes from begin and cursor. And we have a constant. Const. What does this do? This means variables outside of this method in other classes, like not in other classes, in the same class, like contains duplicate. This method has variables like begin and end. We can access begin and end, but we can't modify it. Like how a constant, you can't modify it, but you can access it. Kind of the same thing here. You can access these variables, begin and end, but you can't modify them. That's why we create a new cursor, a new pointer iterator called sorted and end, which is pointer arithmetic of cursor minus 1, which means this is 1 index behind cursor. And then what happens is we compare it. If it's equal, then yeah, they're duplicates. If they're bigger, this is the key. This is the insertion stuff happening. Okay. This is the start of the insertion stuff. This stuff took me so long. It took me 2-3 days to understand. I'm not kidding. I looked at this problem for like 4 or 5 days almost. And this is when I started to learn C++ a little bit more. So I was still starting to learn. I only have 50 somewhat things of notes about certain stuff in C++. So that's all I really know. I'm more of a Python guy, more of a high-level language guy, so kind of, new to this stuff. So obviously, if we dereference sorted and end, and then dereference cursor, and those literals are sorted and literal is bigger than the cursor's literal. My bad. Let me rephrase that. Sorted and literal is smaller than cursor literal. Then return false. And that's gonna make this thing repeat. Then we have insertion point, which is another iterator, iterator pointer, and it equals one of two things. Now insertion point only happens if, let's say you're traversing, right? Whoa. Okay, so alright, so we're nothing's happening, nothing's weird happening, we're nothing weird has. Hold on. Okay, there you go, that's better. Yeah, we're going through, okay? This is pretty sorted so far. They're all in order. We're all in, oops, what is this? They're not in order. We want to swap that, right? Oh shoot, then we have to go back and back until we have a viable place to put it. And then whatever this was before. Okay, that's what insertion does. So what you can do is, there's a pointer obviously that's pointing to the thing that's being moved and pointing to over here, and then they flip it around. Okay, that's what this kind of does. And this lower bound finds what pointer to anchor it on, because lower bound, how it works is if you have a, let's say you have a, I don't know, this, a vector, okay, and it's ordered, and we're trying to compare it to the value 10. Okay, now what this does is it checks if the number, it goes from left to right, and it checks if the literal of that index is bigger than or equal to it. Is 2 bigger than or equal to 10? No. But the thing is just nothing else. If there's something else, then it points to the last thing on that range. So that what this is. Imagine begin is right here, and then cursor is right here, and the reference cursor, pretend this isn't a variable, is 10. Okay, so we're comparing the literal 10, and we create a range with these two indexes, and we are comparing it. Obviously, that means this is pointing to 10, and then we can insert it there, right? So that's what we're going to do after. This only gives you a reference, okay, basically this whole thing only creates a pointer. It doesn't change anything about the vector. Insertion point just makes this becomes a pointer. And then insertion point, if it equals to the cursor, obviously, because then we're moving it, and we know we moved it because that's the only way this would happen. If this is false, okay, if that makes sense. Sorry, this is really complicated. So if the dereferenced insertion point equals the dereferenced cursor, then return true because they're matching. Then you do that whole rotation thing I showed you, and then it moves on to the next thing. So basically, is this smaller than this? Yeah. Is this smaller than this? Yeah. Is this smaller than this? And if imagine this is bigger, oh, then we gotta swap it, go back until there's something that matches, which is what the lower bound does, and then okay, now we can replace this whole thing, rotate the whole thing, and yeah. So this is insane. I would have never thought of this. My puny little brain could have never thought of this. And he does insertion algorithm and compares everything at the same time. I don't know who thought of this. Probably some guy that is a really good table tennis player. I don't know. I'm just kidding. He did. I don't know if he did this or not. Probably not, because there's a lot of people using this. But yeah, that's what this solution does. I think it's really cool. Insertion algorithm and comparing it at the same time, rather than sorting it first then comparing it. It does both at the same time in the same for loop. That's really cool. This is good stuff. The thing I would change about this is how long it is. I would probably just do normal sort and then compare, because it's honestly the trade-off is not that big, unless you're making some like old NASA rocket with only 10 KB of storage in your code, then probably and you want more faster stuff, then you would want to do this. But honestly, that wouldn't make sense if there's only 10 KB. But yeah, that's what this does. Insertion algorithm and compares it if they're equal with all the pointers it uses. And I'm gonna show you this local thing that I kind of did, and it kind of shows you how the pointers work if it's easier. So imagine we have a nums that's 371942658, okay, and we do all that fancy stuff, and now we are, let me just get rid of this. Now we're gonna see what the pointers do. Let's run this. Watch it. Error. Okay, no. So 371942865, okay, and then we have a pointer. This is the insertion pointer, this is the begin pointer, and that's the cursor. Cool, because at first it started at B and C, but we didn't print that out because it hasn't gone to the bulk sort cursor, which is where I put the prints it in, or the couts. And then it next for loop, then we have 371 IBC, makes sense. So insertion points right here. You see, we're not really flopping anything around. Then we see that sorted end is bigger than cursor. Okay, that's a problem. That means we got something to sort, because it's not, in order 1, 2, 3, 4, 5, 6, 7, 8. No, it's backwards. If there's two cursor and one cursor is smaller, but the cursor is bigger, the literal, obviously we need to flip-flop it around. So that's what happens with the rotate. Flops it around. Then this gets moved here in this part, and then that gets moved here, and then that's when it finds again an anomaly that we have to fix. And that's because this value is smaller. We gotta sort it. Then it does the whole flippy floppy rotate. So 4 gets moved here. Everything else gets moved to the right. Okay. Then now we have 2. Now the insertion point has to be here in this range. We're gonna flip 2 here. Move everything to the right. Cool. Now we are traversing one more time. Oh, 6. Lower bound gets us to point here. And we're gonna flip 6 here and move everything to the right. So now we have 6, 7, 9. Oh yeah, cursor here, 5. Lower bound we see in this range, I is right here. Insertion pointer is right here now, pointing here, 6. Because it's the greater number, the first greater number. Flip it around, 5 here, move everything to the right. Okay, one last time, move everything to the right. No, there's no duplicates. So I hope that last bit makes sense, because that nailed it in the coffin for me. Of kind of understanding this. I think I understand this. I just think so. I don't want to be one of those coders in the future that are like, oh, I'm so smart, look at my solution, and I don't proceed to explain it, and I just want you to see how much years of suffering I went through to make this kind of person, you know. This is show off. Obviously, everyone wants to be a show off. Don't act like you don't want to be. It's better to admit to it than not to. We're human. But yeah, I don't know why I said that. That's what that does. Sorry about the long video, but this is a complicated solution that needs its time to be explained. I could have explained it a lot better. This is my first take, so that's why it took so long. I'm going to get better at this. We're going to explain the next solution now. All right, thank you.